Hello guys. Now in this class we are taking the problems of maxima on solid objects, means cone, sphere, cylinder, these type objects, and mainly the questions are based on surface area, curved surface area, total surface area, volume, radius, height, lateral height. Mainly questions are based on these topics. So right now we are taking this question in which the object is 3D object is cylinder, and this is open at the top. So it is just like we have a cylinder, open cylinder, and let us consider the radius of this cylinder is r and height is h. Now we have volume which is given, means it is our given condition, that is volume, and we want to show the minimum total surface area TSA. So this is proving condition, that should be minimum, and the intermediate condition is the height of cylinder equal to the radius. So we want to prove this h equals to r. So it is intermediate condition. So according to this, we will, from the equations, we have a given volume. So let r be the radius of base of cylinder, and h be the height of cylinder. So we have a given volume. So volume is fixed, or you can say constant. So v equals to pi r square h. This is the volume of cylinder, and this is in terms of two variable. So we will convert it. We will get the value of one variable in terms of other. So the value of height in terms of radius is v over pi r square, and this is our given condition. Now proving condition is total surface area. So total surface area, let S be the total surface area, and right now we will include this, but we exclude this. So it is pi r square, and curved surface area is 2 pi r h. So we have pi r square plus 2 pi r h. This is the curved surface area. So it is the second equation, this is first, and this is the proving condition. So right now again this condition, the surface area is in terms of two variables. So first we convert it into one variable. So we put the value of h in this equation. So we get pi r square plus 2 pi r into v over pi r square. So cancel out pi and r. So the final expression of total surface area of open cylinder is pi r square plus 2v over r. So it is that expression on which we will apply second derivative test, and we will prove it minimum. And intermediate condition, we will show H equals to R. So right now V equals to pi R square H and S equals to pi R square plus 2V over R, and this is in terms of R. So when we apply the second derivative test, so ds over dr is the first derivative. It will be 2 pi r plus 2v, and this is minus 1 over r square, means 2 pi r plus minus 2v over r square. It is first derivative, and the second derivative will be d2s over dr square. It will be 2 pi minus 2v, and this is minus 2 over r cube. It means it will be 2 pi plus 4v over r cube. This is second derivative. Now according to second derivative test, we will put ds by dr equals to 0. So it is 2 pi r minus 2v over r square is 0. It means 2 pi r equals to 2v over r square. So cancel out this and this comes here. So it is pi r cube equals to v. And what is v? V is pi r square h. So we will put this pi r cube equals to pi r square h. So cancel out r square to this. So as a result we get r equals to h. This is the intermediate condition and we obtain this. And right now we want to prove the total surface area is minimum. So we put this value in this expression and this should be positive. So we have d2s over dr square. It is 2 pi, it is already positive, and 2v over r cube. So 2 pi, and this is 2 into pi r square h over r cube. So it is 2 pi plus 2 pi, and the r equals to h, so we can place h as r. So it will be r cube over r cube. So cancel out this, we get 4 pi. It means d2s over dr square is positive. If it is positive, it shows the total surface area of cylinder is minimum. Next question. Show that the height of cylinder is equal to the radius. So h equals to r. So it is intermediate condition is which is open at top. We have a cylinder which is open at top having given surface. So the given condition is surface area of open cylinder, it is GC, and greatest volume. So it is proving condition. Right now volume should be maximum and surface area should be given, and the intermediate condition is H equals to R. Again we have a cylinder which is open at top and its radius is R and height is H. So the given surface means surface area of open cylinder which is open at top, that is pi r square plus 2 pi rh, and this expression is in terms of two variable r and h. So first we convert it into one variable, so we will collect the value of h in terms of s and r. So that will be s minus pi r square divided by 2 pi r. So it is the value of height in terms of r. So the second proving condition is volume. So volume of cylinder is pi r square h. So we put this value in this expression and converts the volume expression in terms of radius. So it will be s minus pi r square over 2 pi r. So cancel out pi and r. So we get half r s minus pi r square. So v is 1 by 2 sr minus pi r cube. So this is the volume expression on which we will apply second derivative test. So we have volume expression, v is 1 by 2 sr minus pi r cube. So thus on applying second derivative test, dv over dr, and it will be half s minus 3 pi r square, and the second derivative d2v over dr square, that will be half 0 minus 6 pi r. So we will cancel out this minus 3 pi r, and r is greater than 0, so d2v over dr square is negative less than 0. So it shows the volume of cylinder is greatest. So one more thing, we want to show the height of cylinder should be equal to radius of cylinder of its base. So for this we will place the first derivative equals to 0. So dv over dr, that is half s minus 3 pi r square equals to 0. So 2 comes here and it is 0. So s minus 3 pi r square, so it is s equals to 3 pi r square, and s is pi r square plus 2 pi rh, and it is 3 pi r square. So on subtraction this we get 2 pi r square equals to 2 pi rh. So cancel out 2 pi and r. So h equals to r, means height of cylinder equals to radius of base. So this way we will do the 3D object questions on maxima minima.